Once upon a time, before a douchebag bought it, there was a website called Twitter. I took to it to make a prediction that 5 years later, basically nobody would care about Kubernetes. That prediction was 5 years and 38 days ago because the timing gets weird due to pandemic. I didn't predict that one. As I explained back in 2019 and every year since then, my prediction wasn't that Kubernetes was going to magically go away. I'm not that lucky of a man. But instead, that it would be irrelevant to most people's understanding of their environments, since it would have slipped below our surface level of awareness. Like the Linux virtual memory management subsystem. A couple people really need to care, the rest of us absolutely don't. And we're all better off for it. Now, given that you're all here to attend a talk with the word Kubernetes in the title, I think it's safe to say that I was a little wrong, or completely wrong, with my prediction. And so, as penance for messing up the prediction, after many years of very studiously ignoring the damn thing, the time has come for me to build a Kubernetes of my very own and then make fun of it on stage, which I've spent the last 2 months doing. Pro tip, if you ever want to learn something new, a great way to do that is to publicly shoot your mouth off about it and then get a conference talk accepted. That's called a forcing function. They won't move the conference for you. I know because I checked. But first, who here has never used Kubernetes themselves? Okay. Who here has never heard of Kubernetes? Okay, not a strong Amish showing. Good, good, okay. So what is Kubernetes? For those of us who are oh so blissfully unaware of Kubernetes' history, it started its life as a practical joke played upon the rest of us by Google's clown division. Once upon a time, they actually would go to market for Google Cloud and to ask companies, hey, would you like to run your stuff on Google Cloud? They'd take a look at the application and say, wow, this won't work very well on our cloud, probably because your engineers didn't build it the right way, the way that we build things at Google. Surprisingly, being incredibly rude and condescending was not an effective sales pitch, so they stopped telling that story, but they also put Kubernetes out into the world so that we could start writing things like Googlers might. There were some very smart people there. We know this because for a while, Google would never stop telling us just how smart they were. That's because they absolutely did not have some of the most humble engineers in the world. That's a different skill set, as it turns out. But as a compensation for us, if you wanted to work there but couldn't get past the incredibly rude and offensive hazing process known as their technical interview, the consolation prize that we all get is to pretend that we work at a cloud provider by working on Kubernetes in the various companies we work at. It's a practical joke that they put out that the rest of us took way too far. Like that time that they put out a MapReduce paper, which was a hilarious joke until the other jokers at Yahoo saw it and came out with Hadoop, and then we've had to deal with that ever since. Same principle applies. Now, I originally, when I was imagining this talk, I set out to start doing some hilariously bad things inside of Kubernetes as a joke, like using the etcd control panel for your production database, or using ephemeral nodes to host the control plane itself, using one giant namespace for everything, running it at all on IBM Cloud. You know, the typical things you never want to do. But as I set up my own cluster at home, I realized that I had been beaten to the punch by years because the terrible ideas were in many cases expressed in the actual experience of running Kubernetes. Now, I am sort of a special unicorn on this because I've been intentionally ignoring it, but I'm not a complete idiot when it comes to computers because some parts are missing. And I've found that I'm usually not the dumbest person to ever try to do a thing. And increasingly when I ask, why is it like this, the response is, I don't know, that's a really good point. Yeah, why is it like this? It's a weird skill set. For those who have not heard of me before, I'm Corey Quinn. I write the Last Week in AWS newsletter that makes fun of Amazon for a living because I have no sense of self-preservation. My day job, though, is I'm the chief cloud economist at the Duckbill Group. We're a consultancy that fixes the horrifying AWS bill because it's fun. That means that, okay, I know AWS super well. Let me figure out what it'll cost me to do this experiment on top of AWS. Because I am legitimately gifted at figuring out how much things on AWS is going to cost. So I set out to do the prediction, and it turns out that that is freaking impossible. Now, I can tell you what the control plane is going to cost, 10 cents an hour while the cluster is running. Now, after a year, if you don't update it, it goes to 60 cents an hour for extended support. This is a good thing, because otherwise, you're not going to update or patch your production infrastructure for years at a time. That causes a cost to the rest of us. You should bear some of that. Keep your stuff patched if you want to be on Taylor Swift's internet. It's not that hard. I can also tell you what the worker nodes are going to cost. That's your choice, really, however many you want to have, choose your own poison, etc. But I could not, for love or money, tell you what the data transfer is going to cost. Maybe it was going to be nothing. Maybe it was going to be $5,000. Maybe I should go to hell. And that's a bit of a problem because I have a budget. This is one of my favorite conferences, and I need to make sure that I budget appropriately for it so I can actually go. So a new approach was needed because I didn't have a cloud dependency. Also, can someone help me budget? My family is dying. So I went back in time to my data center days, and I bought 10 Raspberries Pi of varying types that I could cobble together into a cluster. And that was a horrible reminder of the bad old days. I had to deal with all kinds of things, such as ordering parts. The parts don't show up. The part shows up and 3 work and the 4th is defective. Finicky connections that don't quite work. Having to think about a network fabric. The small fire it started in a cabinet, et cetera, et cetera. All kinds of fun things. And there was no cloud involved in any of this, and it had been a long time since I'd built anything like that. And there was something that struck me about this entire process as I was doing it, and comparing this to what my clients had been seeing, and I realized something that makes sense when you start to look at it from a certain point of view and cuts against a whole bunch of people who have something they very much want to sell you, and that I was building a cloud, fundamentally, trying to get Kubernetes to work. Yes, a small, shitty one. Insert your joke here of your choice about a vendor. Yeah, but it's true. Because cloud native is a term that is basically meaningless. In many cases, it means, oh, it runs on Kubernetes. Well, what doesn't these days, really? Because people won't stop talking about it. And in this case, what I was doing was getting Kubernetes to turn a pile of hardware into something that could be reasoned about in something approaching a cohesive sense and abstract away all of the hardware that lived underneath it. Kind of like OpenStack was trying to do if it didn't absolutely suck, or VMware's cloud nonsense back in the good old days. I mean, remember how when we were all younger, we might have pirated VMware? And then the pirates bought VMware, and then they're cranking the cost into the stratosphere and no one wants to use it? Yeah. Now, Kubernetes serves a function, and it is an important one. It abstracts your application away from the underlying hardware that it runs on. Well, guess what, jackhole? So does any reasonable cloud provider. EC2 will live migrate instances off of failing servers. They don't make you do it yourself anymore. A failed hard drive in AWS manifests just a very brief latency spike, and it lasts less than a second. These companies do their job super well. I can't outrun AWS when it comes to doing those things well, and also other things like giving services bad names. I digress. But you start off with all of this hardware bullshit that you have to deal with, and then clouds can sort of abstract that away with their own version of cloud bullshit, and then they wind up pouring the Kubernetes bullshit as another abstraction layer on top of it, and you're left there being extremely confused. Nice vest, by the way. So when you slap Kubernetes into your existing cloud environment, you are introducing a black box of abstraction. To the perspective of the cloud provider, you're running a single application with some really weird behavior patterns, and for all intents and purposes, that behavior remains completely non-deterministic. And oh my sweet stars, it love to be chatty, so you don't really know what it's doing. Well, why does that matter if it's chatty? Because that's where I see it in my client accounts. Cross-AZ data transfer generally costs about 2 cents a gigabyte, and Kubernetes itself has no sense of zone affinity, so it'll cheerfully throw things across the expensive link instead of the free thing right next to it. And despite me whining about this for the better part of a decade, they still haven't fixed that out of the box. So it chatters away on your dime. I get questions then like, so, okay, why is this bill so high? Well, okay, what's moving 2 petabytes every night between these 2 availability zones? And the answer is only found through oral freaking tradition, unless you're really good at interpreting VPC flow logs, which you're not, because no one is good at that nonsense. It's arcane. It's reading tea leaves. So, okay, it's going from this worker node to this other worker node, but what was running on those both at the same time? I must consult the bones, and here we are. So yeah, by running on Kubernetes, you're separating out the infrastructure in such a way from the very fine people at the cloud providers who understand how that infrastructure interacts with different things, and you're baking in a lot of complexity. It's a choice. I am not saying it is a bad choice. I don't have the context to tell you whether it is or not, but it is a decision that you're making. You're giving up something when you make it. Make sure that what you're getting in return for that decision justifies it. Now, I'd be a little less concerned about this if Kubernetes actually did what it says it does on the tin, but I assure you, it absolutely does not. I used to be a sysadmin before I became a DevOps, which is a sysadmin who gets paid more money. I have heard the howling of the data center server fans, and my hands bear the scars of the rack nuts. The lessons of that part of my career are graven upon my bones. I say this because it teaches you things when you go through that level of pain. And one of those lessons is you don't trust anything in production until you understand not only how it works, but how it breaks. So I did the responsible thing once I had my Kubernetes up and running, and I killed power to a running node to see what happens. Well, okay, but who would actually do something like that in production? Meet Dewey. He's the remote hands employee at your friendly local data center. Dewey tries hard, but he's unfortunately accident prone, and he doesn't always understand your company's naming conventions, among many other failings of Dewey. He assumes that you properly label your test nodes with clear descriptions of what they are, like this one, for example. Good job, Dewey. The production database label is how we identify our test nodes. You're batting 1,000. My boss would like to introduce you to an actual bat, but that's neither here nor there. So sometimes nodes, for whatever reason, suddenly fall off the network. So at 2 in the morning, when Dewey rips the network or power out the back of the server like he's rip-starting a stubborn lawnmower, great. Kubernetes should probably understand that a node has gone non-responsive and spin the thing's workloads back up on a different node. So I did that, and the workloads didn't reschedule elsewhere from that unplugged node for several days. So, okay, I reached out to the Kubernetes Enterprise Support Desk, Twitter. Now, you see the 46 responses to that? I learned some things. I learned that Kubernetes doesn't work that way. I also learned that Kubernetes does work that way. I also learned you have to do a whole bunch of other configuration to get failover to work properly. I also learned that no, you freaking don't, idiot. And the longer the responses went on, the more it seemed like maybe nobody actually deeply understands this thing that still gets pride of place in conference talks like this and on resumes like yours. But I do know that if one of my servers drops off the network at some point, and the application that is running is part of production, the odds are apparently terrific that I'm about to get paged. Because we have apparently learned freaking nothing as an industry about graceful failure modes in the near 30 years we've all been doing this. Something else I learned as I went is that Kubernetes does more than schedule containers. It is also a jobs program for an entire ecosystem of companies and engineers that, despite raising billions of dollars in venture capital, apparently can't afford enough vowels to go around in their names, but that's neither here nor there. So almost anything you want Kubernetes to do, it doesn't actually do, at least not on its own. That's when we turn to the CNCF projects. It tags in one of these other things to do them for you. That is the downloadable PNG of the cloud-native landscape, for those who haven't seen that particular monstrosity. An earlier version was turned into a 1,000-piece puzzle that my business partner got me, so I burned his house down. Okay. Now, I understand and I appreciate taking a modular approach to systems design, but this doesn't just approach absurd, it vaults over it into clown shoes territory. Now, many of these things themselves, by the way, are also fractally designed because they themselves are composed of a ridiculous combination of microservices that nobody fully understands. Let's talk about one that I encountered almost right off the bat, storage. In the old days, you would have a big, central, hideously expensive multi-rack file storage system, or honestly, volume storage system, called a SAN, that Dewey would, of course, mistake for a urinal and attempt to pee in because, again, he's not really top-tier employee material. These days, a bunch of systems pooling together their local storage together to handle this and distribute it out is much more common, and a few things provide this functionality. I went one that's called Longhorn because I am a sucker for cow themes. It's kind of like EBS inside of AWS for those coming from the cloud world, complete with its own terrible naming conventions. It seems to have, it's a volume, let me give it an ID that's about as long as the system's firmware dump. Awesome. It adds additional layers of abstraction in the form of nodes, disks, volumes, replicas, volume claims, attachments, and a pretty user interface so you can manage your storage the way that God intended with ClickOps. That's the theory. So I spun it up, and it got right to work doing apparently what it does best, suddenly and violently shitting itself to death in a constant loop. Now, it turns out that this was not just me being cursed. There was a low undercurrent of people reporting stories on this over the years. Oh, so I opened some issues. Okay, great. You're running it on Raspberry Pi? Yeah, those aren't powerful enough. Closed, won't fix. Okay, but the metrics of the node show that these things are all sitting around board. It's not a resource starvation issue. Well, you're going to want the volumes to live on SSDs. Closed, won't fix. Yeah, well, they already do, see? Oh, then you're probably going crazy. Closed, won't fix, and so on and so on. Helpful group of people over there. I turned down the generous suggestion to go buy a $250,000 SAN since I was going to use that money to run an AWS-managed NAT gateway for almost a week. So a bit of experimentation combined with an awful lot of digging turned out that there are all kinds of interesting other closed, won't fix, go away issues over the years. That Longhorn is battle-tested and completely bulletproof until and unless you commit the closest thing our industry has to a war crime and restart the projector. All right, it had to stop and think for a minute. Same projector, same. Yeah, and ask it to follow a symlink or something. And then it falls completely to pieces. Now, when I replaced the symlinks that I had mounted to the storage pool on these things with bind mounts, the problems evaporated as if by magic. Well, everyone knows that. No, Professor, they don't, I promise. I mean, I get it, though. Symlinks are relatively recent enhancements to the Linux kernel. Support was added just a few years ago in 1992. So I got it up and running. Unlike so many people who give conference talks on Kubernetes, now it was time for me to actually use the thing. So did you know that Kubernetes has a command line tool? In a classic example of missing the forest for the trees, instead of focusing on the big problems with this tool, such as, engineers getting repetitive strain injuries from having to type out all the goddamn flags and options it needs to do freaking anything, the universe instead spends its precious development time arguing about the other most important thing, how to pronounce the tool's name. Kubectl, 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 and that damn thing. Yeah. I'm increasingly of the opinion that the actual kubectl developers probably don't actually have any friends. Therefore, they don't ever have to say the term out loud, so it never occurred to them to figure out the pronunciation guide. This also, it shouldn't really be one massive tool. With this many options, it really does present as more of an operating system, like Emacs. So tell me what happened in my cluster. I ran kubectl get events, and for those who can't see, because of course it doesn't know how to say things concisely, the events show up from, there's one that happened 3 minutes, 5 seconds ago, a bunch 37 days ago, one 2 minutes, 59 seconds ago, one 47 minutes ago. Do you know that it doesn't return events chronologically by default because that's apparently hard? Maybe I should check and see if anyone else has ever noticed this behavior. Well, wouldn't you know, they did 8 years ago, and it's still not fixed. You see that there are 46 comments there on that issue? Guess what, fools? Those comments are in chronological order. I wonder why. Imagine that. The fix, by the way, which doesn't actually work most of the time, is to use apparently a completely different subcommand, and it still doesn't always work. It has a different weird order, but it's still not the one you'd want. And what is this? I am this ancient dinosaur who grew up in a time where we used text files to record logs, and you would append the latest event onto the end of the text file. These things will return in any order they want that is not chronological. Okay, I'm done. No, I'm not. Okay. When challenged on this, the community's response, by and large, has been, event ordering is hard. Do you want a recurring event to show up the first time it showed up or the last time it showed up in the ordering? Well, I don't know, Jimothy, but I do know that events that happened 4 seconds ago probably shouldn't get masked by things that happened a month and a half back. But what do I know? I'm not a Kubernetes engineer. Don't worry, though. There's an easy way to get it to tell you to spit things out in order. And I'd love to know why that monstrosity is not the default. Why do I have to remember whatever godforsaken arcane syntax that thing is using to spit out the events in order? Okay, now I'm actually done on that. But unlike every other talk that I've seen about Kubernetes, which largely seems to be purely in service of running Kubernetes itself, let's turn our attention for a hot second in the direction of the putative reason that we're running this thing, the actual applications that live on top of it. I've got a bunch of them. One that I've been looking for years is called change detection. The .io is the actual official domain. It's great. It checks web pages periodically, and it alerts me if they've changed. It comes prepackaged as a container, but getting it into Kubernetes was quite the treat, as it turns out. Here's the config. They're broken into 5 files, which you can decide to do arbitrarily or not, but there are 5 separate components I, as a human, have to manage for this. You've got the deployment, which means the container in question, the service, so I can hit it with a web browser, and there's a dependency as well on a volume for the thing that needs persistent disk. Cool. You could put them all in one file, and it would be 111 lines of YAML, which is apparently what senior engineer means. You write YAML. Great. There are no comments in there because YAML, and all those lines are needed. They interrelate with each other, but you do have to manually specify it every time you build something like this. Now, to make changes to this service, I can either edit one of those files and then apply them to the cluster, or I can lose my goddamn mind and YOLO slam that bullshit into place, assuming I got the brackets correctly balanced, and now the files that I have describing the state of the deployment are no longer accurate. The next time they will get applied by an automated system like ArgoCD or GitHub Actions or whatnot, what happens? My change gets stomped. The thing that this command got running will get wrecked. And we figured this problem out many years ago with configuration management. Kubernetes wants to discover everything from first principles, so we get to learn it again. Speaking of ArgoCD, for those who haven't played with it, it is pretty great, if a little bit wordy. It's CI/CD for applications deployed onto Kubernetes. The website says ArgoCD is CI/CD for Kubernetes. Some people like to say it can be used elsewhere, but okay, those people are excited. Maybe the project team lacks imagination. For example, I've not seen a single thing come out of them called JSON and the Argonauts. It's a lost opportunity. There's my classics, friends. Okay. Let's talk about Helm, which is in theory a package manager for Kubernetes. In theory, penguins can fly if you launch them hard enough. It's very tricky to modify anything that Helm provisions into your account or your cluster and maintain upstream compatibility with the Helm chart, which is their term for package. Great. Whomsoever made this chart can set up a list of values that you can override or set to customize the parts that they think should be customizable. In practice, it means that they lack all imagination, like someone naming a service at AWS, or ability to step outside of their own use cases. It gets on full display, because why would someone want to run any of these applications on, I don't know, a Raspberry Pi? That would be ridiculous. Sounds like something a lunatic might do. Let's also talk about the lack of care, clearly evidenced by the way some people actually deploy Kubernetes in the real world. Let's say that I'm running a DNS server inside of my cluster. Bam, because I need a database. Now, Pi-hole specifically is what I'm using. DNS is a database. I will fight you if you disagree on that. It's true. Best database in the world. Now, I use Pi-hole because I don't want my IoT network to phone home reporting on things that are frankly none of the rest of the world's business, like how many times I do, in fact, open my refrigerator late at night. Remember, it's not a dad bod, it's a father figure. Thank you. Now, many production environments also run their DNS servers inside of Kubernetes clusters. The difference between some of those production environments and my own crappy one is, unfortunately, that I have triple-checked that the DNS server itself is not needed to boot the entire cluster from a cold start. Now, clusters rarely get turned off completely. I get it. That makes sense. Which has the unfortunate side effect that people sometimes lose sight of the reality that when it finally does happen, to get it back up, you absolutely cannot have that process depend on anything living inside of the cluster. Well, okay, it's not like some of the companies I've seen do this are doing that important work. I mean, one of them was only a bank. Let's talk about bad job titles for a second. There's DevOps, as we said. It's like a sysadmin, only, pays better. You've got SRE, which means that you are a DevOps in the Mountain View region of California. Otherwise, you're just a sparkling DevOps. You've got DevSecOps because, hey, security's tired of being the Department of No, but security doesn't know how to not butt into things, and here we have them there. And you have platform ops, which means, hello, I have something to sell you this week. But the absolute worst job title that you absolutely don't want is, of course, load balancer. That's just a thing for computers, not for people. Please don't make me do that by hand. Now, Kubernetes supports multiple network load balancers itself. Awesome, makes sense. Most of them expect you to be in a cloud provider, but there's one that doesn't, and it's called Metal LB. First released in 2017, accepted into CNCF in 2021, and the first thing on its website, of course, is a protestation that despite it still being in beta after 7 years, like a godforsaken Google product, it is totally stable and you should trust it in production at the bank. Cool. It's been stable for me, but okay, fine. It touches on yet another underlying problem in Kubernetes here. Specifically, that every load balancer out there is a little bit different in how it thinks about things and how it interacts with the environment and the things you ask it to do. It's a classic thing I like to tell people about the dangers of multi-cloud, where you expect that, oh, everyone has a load balancer. Yeah, but the way that they work, the way you provision them, the way you call them does change. The way they break changes, and you have to start planning for that, which is why on some level, when someone goes multi-cloud hard enough, they build their own load balancer inside of a cluster. Okay. And its interfaces, as a result, are all relatively undefined. And that means that the behavior of each one of these is different, and they can only really address in Kubernetes the common cases. Pop quiz. DNS servers listen on port 53. Is it TCP or UDP? Yes, exactly. The answer is yes. Because UDP is what thing you query it with, and it will respond. TCP is needed for zone transfers, also known as database replication, or if there's a truncated response over UDP, the client has the option to retry over TCP. So I tried this to turn both on, and it turned out that it just didn't start a UDP listener on the service, just TCP. I removed the TCP option, and then UDP started. What the hell? Turns out if you want both on the same IP address, imagine that, you need to come up with a specific config for the load balancer you are using. Here is Metal LB's. In this case, you have to say that it is allowed to share an IP with an arbitrary string that they use as a key on this. Now, if I want to move this service to another cluster with a different load balancer, well, none of that is going to work, and I have to program defensively around it. And it's hard-coded, too, for what IP address that's going to be. So it's not portable. Maybe I'm missing something in how to get this to work properly, but this example is copy-pasted from Metal LB's documentation, so if I am wrong on any of this, please share it with those folks, too. It is an issue in Kubernetes. Don't worry, though. This one has only been on the roadmap to fix since 2016. They said, OK, we got it fixed, and having torn through it, it's clear the fix did not take for all edge cases, like, a non-cloud load balancer. Closed, won't fix. There's a lot of that goes around. OK, I'd be remiss if I didn't talk a little bit about observability, just a smidgen here. Now, What observability is, it started off as monitoring, and then they decided to fix the biggest problem with monitoring in that it wasn't expensive enough. So, in seriousness, there were some other changes too. Like, okay, this container stopped existing 20 minutes ago. You better have enough telemetry to figure out why an error happened. It became a murder mystery. It was glorious. Welcome to microservices. So I instrumented my Kubernetes with a few things in this space. I use Axiom for logs, Honeycomb as an OTel metric target that I can just send all those things to, Grafana or Prometheus within the cluster itself, so I could get a pretty dashboards of my nodes overheating because of previous comment about small fire. Great. And something I noticed is that since I began this experiment in late January, it's thrown a 1/4 terabyte of logs despite not doing a hell of a lot. That's almost 130 million events that it's submitted despite, again, not doing a hell of a lot. So that's something that I don't really understand, because it basically never shuts up, but also never does a damn thing that's useful. Raise a hand if you have a coworker like that. Yeah. I've been that coworker for some of you. Yeah. Now, before I wind up wrapping, I want to make sure here that I don't sound like a total downer on Kubernetes. So let me highlight the actual good parts. And there are some. They're there. They're just generally a lot less funny. For example, it's basically the closest thing we have to a multi-cloud API. That last load balancer problem aside, it works reasonably well at it. I've been saying for a long time that multi-cloud is not a thing as imagined by people who espouse it the most. But the reality is everyone's multi-cloud. People are going to run infrastructure on AWS, but if you're doing that, you're not going to use their code commit product for Git because you have a small problem called still having self-respect. So you're going to use something like GitHub. Okay, great. You're going to use G Suite or something like that over in Google Land, and these days you'll send something anywhere that can sell you a NVIDIA GPU for the right price. We've seen that everywhere. So that is the way that the world works. So everything has to interoperate on some level. Data transfer remains prohibitive, egress remains obnoxious, but you do have workloads that will need to be deployed in multiple places, and Kubernetes makes that a heck of a lot simpler. If any of you have snuck in from Amazon's branding group, I know that's not your actual logo. In fact, all 4 of these are using older versions of their logos because I'm a small, petty man like that. I know they replaced the box logo with the AWS smirking at you. That wasn't foretelling anything. K9S, anyone use it? Oh my God, you all need to use it. It is a text-based user interface that has a psychotic enough logo that I didn't have to edit a damn thing to put it on the slide. It's great. The actual interface is awesome too. You can drill down into all the different things, deployments, containers, pods, look at the logs from anything. You hit a button, it'll automatically do a port forward to your local machine, and you can hit whatever service it exposes on localhost. It is effectively an awesome way of just reasoning about all these things, and oh my God, is there a lot of typing and tabbing between all these different things because nothing is unified because we aren't allowed to be happy anymore. And it does segregate optionally by namespace, but it doesn't require that. So you can actually see things cohesively as a unified whole, which is a big step because namespaces are incredibly important within Kubernetes, as it turns out. Because if you're in the wrong namespace or forget the namespace option, it does its level best to gaslight the living shit out of you. What pods are you talking about? There have never been pods here. Are you feeling okay? Yeah, it's great. It doesn't actually ask you if you're feeling okay because I assure you it does not care. It really doesn't. It's also, and look at the other options too. I mean, let's do a car analogy because every engineer loves those. You can view Docker as a bicycle. It gets you from A to B, but there's an awful lot of work involved with doing it. There's a Docker Swarm, which, much like the Pontiac GTO, hasn't been really advanced at all or made in 20 years. Then on top of that you have Docker, Docker Compose. The Compose is still with us. Swarm is the Pontiac. Yeah, then you've got the Honda Civic hanging out with, that is Docker Compose. It's reliable, it works, it gets you from A to B, and everyone uses it for something. And then you've got basically Kubernetes, which is like the F-35. It's incredibly complicated, it can't fly in the rain, and it's estimated to cost $1.7 trillion to develop and run. I mean, I kid, but there is another value here too, which is none of you would be here if this were all about terrible ideas in Docker, terrible ideas in Docker Swarm. You're here because it's an exciting technology. I made a joke earlier about the resume side of it, but it's true. I was talking to a friend who runs a company where all of their customers are cloud-based, but because of the nature of what they've built, they run it on-prem. And they absolutely call out that hiring is a problem because they're finding people who are excited to work in on-prem environments. The same can be said of Kubernetes. People want to have the thing on their resume, ideally, that is portable, that you can pick up and take with you to another job, instead of, I got very good at this one company's specific applications and processes around it. Plus, with Kubernetes, let's be serious here, everyone's using something a little bit different. You're using different load balancers, different storage systems, different ingresses, different CI/CD pipelines, different everything. So one person's Kubernetes usually looks nothing like someone else's. We're all building unicorns on some level. I keep waiting for a bit of a thinning of the CNCF landscape. It hasn't happened yet, but who knows? Maybe they'll just start, I don't know, taking heads or something over at KubeCon EU this weekend. Who knows? And there's one more benefit too, which is that nobody else knows how to use it either. Because every person I've really sat down with over the last couple months, when I start really asking the tough questions, it didn't take long at all to get to, ooh, I don't actually know the answer to that. Yeah, none of us do. We're figuring it out as we go along. And there's solidarity in that. There's a sense of peace in that, oh, thank God, I'm not a complete idiot, or at least if I am, I'm in very broad, very good company. This stuff is complicated. It has introduced a lot of complexity, and that is collectively a decision that we have all decided that we're okay with. Maybe it works out, maybe it doesn't. I just get to sit up here and talk because my primary skill remains wearing a suit. Now, later I intend to do other talks in this series. Terrible ideas in EKS for the AWS folks. Terrible ideas in GKE for Google Cloud. Terrible ideas in banging stones together for IBM's version of it. The usual stuff. I'm also going to be here giving an Ignite talk in about 90 minutes where I wind up talking about generative AI with just glowing things to say about it. And of course, sign up for my newsletter at lastweekinaws.com to get my sense of humor like this in your inbox every week. Because if there's one thing people love, it's a sarcastic jackass with opinions. Thanks for listening. You're free to go. You're also free to basically assault me with questions, but the answer is going to be, I don't know. I have Gen AI now to wind up confidently being completely wrong. I don't have to deal with that anymore. I've been replaced. Awesome. What do you got? Yeah, is there actually a need for Kubernetes, or is it a giant scam run by DevOps people? It's a fair question. The reason I believe there is an actual need for this is that I don't know if you've met a lot of DevOps people, but they're not exactly what one would call persuasive. There are reasons to do it. It solves problems. Again, before this, separating out the application from the underlying hardware was hard to do. Virtualization got us part of the way there. Containers made it easier, but scheduling them is important. Needing some sort of overriding supervisor system to do that is something that was no longer optional. I've talked in seriousness with folks at Google, and they said that their Borg system internally is what they use for this. And when they started developing Kubernetes internally, they basically had two problems. One, well, we can't use all of the other dependencies that went into Borg, so we have to build things like this for the rest of the world. And two, yes, we can redo the system and not make the same mistakes. So instead, they made different ones. That's always the way of second systems. The problem that you'll see, though, is that it's being used for cases that I find relatively unconvincing or uncompelling. Everything that I'm running on that tiny little cluster would be just as well served as individual Docker containers running on a spare host. I still have a single power supply into this thing. The small to mid-size fire is still going to take out the whole thing. I'm not saving myself anything particularly useful there. I was mostly able to solve I can restart individual nodes for patching and whatnot, and none of the applications seem to notice or care. but it took some work and some testing and some tweaking of those individual workloads. I will say, to Kubernetes' benefit, there's a strong demand for operational experience in the industry. And if you've worked on it in one place, you've learned a lot of transferable things, not necessarily tied to exact implementations, but it shows you know how to think about things like, okay, maybe it's not all just one giant monolith. Maybe you have a microservices story. Maybe you have to think about distributed storage. Maybe you shouldn't use etcd as your primary production data store, et cetera, et cetera. Whether or not that is the subject of a conspiracy, it's comforting to believe that it is, just because it would be nice to think that someone was that persuasive and had the ability to see far enough ahead for that kind of outcome, but I don't buy it. I really don't. Sure. That's when I pay you to handle running Kubernetes for me. The question is, well, what does a train look like on that projection? Yeah, I pay someone else to make it their problem. The joy of public transit. Honestly, it's kind of what you do with cloud providers on some level. I promise, they are way better than fixing failed hard drives than you are, and light years better than Dewey. Of course. Dewey's actually an amalgamation of like 3 or 4 people I used to know at various data centers who were not the sharpest on the third shift when it came time to. Now, make sure you restart the proper server, or don't, like, there's a reason that we hang fiber in loose bundles. Tightening that down for us was surprisingly unhelpful. Now, you're going to help us rerun that all. The original Call of Duty at 3 a.m. That's right, it's Nagios. But yeah, Nagios had a big problem. It wasn't expensive enough.
I have a question.
No.
So as a cloud economist, do you think Kubernetes is a good tool for cost containment, since it's doing time sharing?
Do I think it's a good tool for cost reasons? No, I think every time you're running it, you're seeing that it winds up driving additional cost unless you approach it from the position of cost-aware architecture. It is, as deployed in many cases, not optimized at all. And to people's credit, when you're deploying an application and building and scaling it, you're not sitting there thinking, now how can I do this for the least possible amount of money? At least not the good places. And because you don't really see success from that. You build it, make it work first. There's opportunity to optimize later. But data transfer remains incredibly poorly understood. There's a lot of questions about how densely you pack these things. Do we go with a few big instances or a whole bunch more smaller ones? God forbid you're running anything that license on a per core count, because that becomes nightmarish. There's benefit, or anything that's on a host basis, okay, so it'll save us money if we make bigger instances. Yes, but it will increase your blast radius should one of them go down. How long does it take to get a new capacity added? Auto scaling is great. It gives you the capacity you need 20 minutes after you need it. So you've got to plan ahead for some of those things. Hit me with
Corey.
it. What do you got?
Thanks for coming to Pasadena. This is my first scale. And thank you.
Yay!
What type of companies normally call a cloud economist, like number of people work there? And then what's the biggest cost savings you've ever gotten?
Oh, geez, that's a bit off the beaten path on some of these things. Honestly, it's more about large companies spending, significant piles, but it's less about saving money, which is what I think something that throws people for a loop. It's about understanding and predicting it, because otherwise, if it just comes down to saving money, it's not that hard to do it irresponsibly. Like backups, what are you, some kind of a coward? Or, overhead room, like anyone would go to visit your website. It's fine, turn it off.
Thank you.
Of course. Other questions, concerns, criticism? Feel free to call bullshit on everything I just said, by the way.
So you mentioned managed services. For like AWS, I've experienced managed services are great because they don't work.
Mm-hmm.
And then support says, hey, you remember that shared responsibility model? We're going to throw the ball over the court. I mean, they are better at something, but when it doesn't work, it really sucks.
Yeah, the question was more around challenges about managed services, and when they don't work, how do you avoid the being finger pointed over to the shared responsibility model? That's always the problem whenever there's interoperability anywhere. You see it even internally in the in companies. If you don't believe me, go and report a problem with the network to your network team and see how quickly. Have I tried using generative AI to fix any of this stuff? Well, I did ask it a couple of fun questions that were interesting, and it gave the answer of, oh yeah, that's a neat part, you don't. Great, not particularly helpful. Gen AI is fun just because it's very good at giving a surface level overview of something, but if you start pressing it on something you know about, it turns out it doesn't know much. And then you start to realize, wait a second, no one seems to know the answer to that. Oh dear. Then you forget that. You asking for stuff on something else, like, well, okay, so it's terrible at getting Kubernetes up and running. Ugh. Now, it should really tell me how to perform CPR. I need to know that in a hurry. Yes, hit me with it.
So let's say a large organization like this thing that you're thinking of, like who should be, or who should be making the decision to use Kubernetes?
Who should be making the decision? Ah, dear Lord. Yeah, who should make a decision to implement Kubernetes there? Ideally, not you. And I say that with all sincerity, in that you probably don't want to be the person holding the bag when you implement something and it doesn't work out super well. Spoiler, at infrastructure level, everything is going to have problems. Usually, I've seen Kubernetes rolled out because there's a new CIO in town trying to drive change. In practice, the actual thing that drove more change than any other 6 CIOs in a company's history was, in fact, COVID-19. That's your digital transformation that hit. But by and large, I see it coming to solve specific problems. I also see teams going ahead and implementing it because it is the shiny hotness. It's a decent way of running things in a repeatable, declarative way, and that's important. I don't have a whole lot of better answers. I mean, ECS on AWS is great, but I'm also not necessarily going to propose things that have no equivalent in other providers. So you don't want to have a strategic lock-in in that particular sense. I get it. So I feel like the answer is often fine, Kubernetes, I guess. I don't see people super excited to be rolling it out and deploying it, except the technologists that want to play with it. But I don't generally want people who are really excited about the technology because they heard good things about it to necessarily do the entire technology selection process. It depends. Other questions, comments, concerns, criticisms?
So you were mentioning the data transfer costs being a wild card, basically.
Yes.
Have you heard about EKS being a hosted Kubernetes platform being any better at that? Since theoretically Amazon should put some magic on top?
That handles the replication traffic between the control plane. You're right. It doesn't charge for any of that. But I'm talking about where I see it is not the control plane itself being chatty, but rather the individual workloads that live on top of it. Where, okay, you've broken this thing into microservices because every outage needs to be a murder mystery. So I have the application wanting to talk to Redis that just happens to now be located somewhere else instead of right next to it, or multiple things in service discovery. Rochambeau decides it's going to talk to that one instead. But the hardest part for things like that is just tracking it down and being aware that it's happening. The way to avoid it is multiple clusters, one per availability zone, but it runs counter to what most people instinctively think should be done. Like, wait, single availability zone, that could cause problems if AWS loses an AZ. Yeah, but how often does that happen on a global basis? Not as often as you're going to trip over yourself because you misunderstood something there. Again, it all depends. Like in my tiny Twitter for pet scale startups thing, I enjoy having, I don't need to be multi-AZ. If it can be down for an hour. Most of my bullshit, if my site's down for an hour, the internet's a better place for it.
Debatable.
There's also this idea that downtime is incredibly expensive. For some companies, sure, but for other companies, it doesn't really matter. If you're displaying ads to people, great. Then, yeah, downtime has an actual real cost. If you're selling something that you're the manufacturer for and your website's down for an hour, well, a lot of your customers are going to potentially come back after the end of that hour. If you're always down, they won't come back eventually. So it's a sliding scale. It's what are the contexts of your business? A lot of back office stuff where their only customers are large entities and they're doing batch processing and their response is measured in a calendar still have to sign ridiculous vendor assessments that demand 5 nines of uptime. It's really? Because that's not actually how this relationship needs to work at all. What template did you steal this from?
So I have a question over here.
Oh, hit me, please.
So I've been working with Kubernetes roughly about a week, actually, so less than 2 months than you. But I found it that it's when you use the Kubernetes operator, for example, like the Kubernetes Kafka operator, I found that it greatly simplifies the deployment of something as complex as that.
Yes.
I've done that manually before, component by component, and it sucked. But with the Kubernetes operator, an install of a Kafka cluster and all its necessary components was a breeze. So I think that's one of the things I'll call you out on. It's actually simplifying the deployment for these type of.
You're absolutely right. I have a tailscale operator in my cluster to put all of these, some of these workloads onto my tailnet, which is great. And in this case, it works super well. The counterpoint is that if I need to start modifying how I want these things exposed on the tailnet, I will no longer be able to use the operator past a certain point of configurability. I don't. I'm not basically a network terrorist anymore. But for things like with Kafka, I could absolutely see a story where for certain tuning reasons, I might need to do something that the operator as written doesn't necessarily work for. So then I'm left with either doing it by hand or patching the operator. Like honestly, on some point, when you start seeing things at significant scale, almost everything winds up being patched locally.
So I think the larger companies, not the smaller ones, actually have a team supporting implementing their own operators.
Yeah, the scary part is that the big companies, they have every team implementing their own operators because they're not allowed to talk to each other. But yeah, that's the fun. What do you got?
Speaking of network terrorists,
Yes.
What are your thoughts on service meshes?
Service mesh is how it pluralizes for starters. And it's, I haven't gone deep with them lately. It just isn't something that I want, at this scale, I don't really have problems that look a lot like that yet. And when I looked into it briefly, it seemed that everyone was more concerned with talking about how the others suck than talking about the specific benefits that they offer. And if I want to wind up seeing that kind of kitten-based slap fight, I'll just go and talk to more observability vendors. Anything else, or should I let you all out a couple minutes early?
Okay, if there's no further questions, why don't you join me in thanking Corey for this great presentation?